Welcome to Episode 6 of Flat Earth Straw Men. A straw man is an intentionally misrepresented form of an argument, which is substituted for the actual argument because it's easier to defeat. Taking this approach is a fallacy called attacking a straw man. I will be doing the opposite, exposing the straw man, to reveal how it differs critically from the real argument, and then providing support for the real argument. Another definition of straw man is a person regarded as having no substance or integrity. So the title of this series serves two purposes, as it highlights how little substance there is to the Flat Earth movement and the unprincipled charlatans who propagate it with dishonest tactics. Today I'll be looking at two videos by Kyle Adams, the self-styled professor of the Flat Earth Institute of Science. One of his videos addresses the sun and whether or not it does or should change in angular size as it moves along its course through our sky. The other video is a rare bird among Flat Earth videos. He admits to concocting a straw man while comparing maps of Australia. I hesitated to make this video because Kyle comes across rather politely in his live videos, his open forum nights, and his one-on-one chat with Flat Earth Math. But his tone in the comment box and his creeping disingenuity have forced my hand. He's also blocked me from commenting on his videos, presumably because I pointed out the dishonest tactics he uses. Either he's disingenuous on purpose, or he's woefully undereducated to present so-called science videos on the topics he has chosen. I'll let you decide. Here's the first video.
Here's a yardstick on the floor. Now watch this ball shrink as we move it across the yardstick. This is what globe earthers claim the sun should be doing on a flat earth.
So here Kyle slides a wiffle ball along a yardstick on the floor. Note the direction of movement away from the observer.
Alright, now here is a yardstick on the ceiling. Now watch as this ball moves across the stick on the ceiling. Does it appear to shrink to you? It's moving the same distance.
Now he places the yardstick on the ceiling and moves the wiffle ball along it. But surely you can see what he's done differently. This is the first dishonest tactic.
Now where do we see the sun? On the floor or in the sky? Can you see how people either intentionally or unintentionally misrepresent the flat earth here?
Now he uses another dishonest tactic, comparing the wrong variable in his two demonstrations. It's not the floor or the ceiling that matters, Kyle. It's the direction of movement relative to the observer, and I can prove this. Hang on. There we go. Let's watch his two examples again, this time with the video flipped.
There's a yardstick on the floor. Now watch this ball shrink as we move it across the yardstick.
See, the yardstick is now on the ceiling.
This is what globe earthers claim the sun should be doing on a flat earth. Alright, now here is a yardstick on the ceiling. Now watch as this ball moves across the stick on the ceiling. Does it appear to shrink to you?
See, now the yardstick is on the floor. See, it's not the floor or the ceiling. It's the direction of movement relative to the observer. The rest of the video argues from ignorance that we can't know just how far the sun is traveling because the firmament could be refracting and magnifying it, and we just don't know by how much. Enough of that. On to the second video, about the size of Australia.
Okay, so let's figure out the dimensions of Australia. According to this article about people who have walked across Australia, Australia is 4,030 miles across from east to west, and it's 2,290 miles from north to south.
So we start with Kyle and his wife trusting a Wikipedia article to provide the dimensions of Australia so that they can compare the representation of Australia on the Gleason map with globe representations of Australia. Did you spot their mistake? Let's listen one more time.
So let's figure out the dimensions of Australia. According to this article about people who have walked across Australia, Australia is 4,030 miles across from east to west. And
His wife said 4,030 miles from east to west. It's really 2,500 miles from east to west. So the width they use is going to be off by a factor of about 1.6.
it's 2,290 miles from north to south.
Let's keep things simple here. We'll make 1 inch represent 1,000 miles. So that puts us at about 4 inches across and about 2.3 inches down.
Now Kyle draws a box with the wrong proportions and attempts to fit Australia into the box with predictable results. The Gleason map ends up being the least inaccurate.
To see how inaccurate this is in comparison with those dimensions.
Okay, this is apparently an acceptable margin of error for him. And then he compares it with others.
Let's try to fit these into the dimensions as best we can. Okay.
Much more inaccurate than I was expecting.
And there you have the margin of error from the globe. Let's skip ahead a bit to 438. Because this is their big reveal from this video.
Wait a second.
Wait, what's going on?
They know they used the wrong width. They admit in this video that they built a straw man Australia.
So we accidentally said 4,030 miles across? That was the kilometers, not the miles. It's actually 2,500 miles across.
So they're now going to repeat the exercise with the proper dimensions. We will watch this because their commentary is worth paying attention to.
Now drawing in our margin of error. Now duplicating our dimensions.
Okay, that's a huge margin of error, first of all. Obviously much larger margin of error than their previous Gleason map comparison. So, continuing.
And here's our other map of Australia, which appears to fit about perfectly.
It appears to fit about perfectly. What an amazing admission from a flat earther. But they're not done.
Wow, that is suspiciously perfect.
It's suspiciously perfect. It's too perfect. It's too correct. It's too close to the values that they were given. So what do? They become suspicious of their source.
Now, looking back on our article with more scrutinous eyes, I think it's pretty odd that their numbers were so exactly proportional.
So, she claims to be looking at the article with more scrutinous eyes. But their commentary here is priceless because it reveals their inability to read more than a few sentences in on this Wikipedia page. I'll let them blather on for another few minutes, a minute or so. And then we'll dissect their flawed rejection of the source that they originally trusted.
You know, I truly doubt they walked perfectly straight lines all the way across Australia.
Great observation. After spending some time doing land navigation with the Army, I learned people very rarely travel in straight lines over long distances due to all kinds of different obstacles.
Yeah, absolutely. Australia has some pretty intense mountain ranges that these walkers would have had to traverse. And switchbacks can really lengthen out a hiker's journey. If you were to take those into account, Australia's proportions would certainly get warped, particularly among Australia's biggest mountain ranges. I think it is pretty likely the author of the article just lazily drew a line on a pre-existing map and said, this is how far they walked, rather than taking all those switchbacks into account and measuring how far they actually walked.
I really agree with you on that. So we can't trust that article.
So there you have it. They can't trust the article because the people walking across the country wouldn't have been walking in a perfectly straight line. Let's look at this article. Let's try to read more of the article than Kyle and his wife. People who walk across Australia can walk from either the geographical extremes of the continent or from directly opposed cities on opposite shores. Then a few of those locations are named. The distance between the east and west, as the crow flies, not as one walks, but as the crow flies, is about 4,000 kilometers, or about 3,700 kilometers from north to south. Distance calculated by author using the resources of Geoscience Australia. Oh, so now we know how the author got those distances, not by lazily drawing a line on a map and saying this is how far they walked, but by using Geoscience Australia. If we look at this image here, this is not representing paths that people walked. Nobody's saying a person walked along the Tropic of Capricorn or walked in a straight line from Darwin to Hobart over the water, or from Southeast Cape to Cape York Peninsula, or from Brisbane to Perth, or from Cape Byron to Steep Point. No one is claiming that people walked on these straight lines. Walkers who choose to circumnavigate Australia can follow the National Highway for large sections of their journey. Of the people who have successfully circumnavigated the continent, it took a range of 365 to 897 days to complete. Distances involved are in the vicinity of 14,300 kilometers or 17,000 kilometers, depending on the route taken. So, for those who choose to circumnavigate the country, in other words, for those who go around the perimeter of the country, they travel anywhere from between 14 and 17,000 kilometers. Now, if we were to treat Australia as a rectangle, okay, just as a rectangle, the dimensions would be about 4,000 kilometers wide and 3,700 kilometers tall. Add those together, and you get 7,700 kilometers. If you multiply that by 2, you get the perimeter of a rectangle, which, if my math is correct, 7,700 times 2 is 15,400, which is pretty well in between 14.3 thousand and 17,000. Let's look at Highway 1. Let's look at this route that goes around the country, around the perimeter of the country. Okay, you see that it goes almost around the complete perimeter of the country. How long is this? Approximately 14,500 kilometers. Again, this value coincides with a rectangle of approximately the dimensions that Australia has. But if we look for kilometers being mentioned down here, we have people who walked around mainland Australia and traveled 15,000 kilometers. One person walked from Port Augusta to Burketown and traveled 2,500 kilometers. If you plot those on a map, you can see what the straight line distance is versus what he went. So it goes to show that Kyle and his wife didn't really read this article. They got about this far in, and they probably looked at this image, and they based all of their conclusions about the reliability of this article and this map on just these two pieces of information and ignored all the rest. Now, the reason I bring up this roadmap image is because it has a special feature on it. It has lines of longitude and latitude. So does this USA roadmap. It has lines of latitude and longitude. If we look at the lines of latitude and longitude, we can see that the lines of longitude are getting closer together as you go to the north. And we can see that the lines of latitude are arcing downward. They're making smiles. If we look at the road map of Australia, and we look at the lines of latitude and longitude, the lines of longitude are getting closer together towards the bottom. The lines of latitude are making upside down curves. They're making frowny faces. Now, why would the direction of these lines change? Why would the lines of longitude be getting closer together at the bottom instead of closer together at the top? And why would the lines of latitude be curving downward instead of upward? Well, that's because we're on a globe and not a flat Earth. the Gleason map, and any azimuthal equidistant projection you want to come up with, those maps are not accurate representations of the distances, especially south of the equator. And that is why on the Gleason's map, Australia is so stretched out and distorted, because on a Gleason's map, these lines that are getting closer together, on a Gleason map, they get further apart. And on a Gleason's map, these lines that are curved as frowns, on a Gleason's map, those lines are forced into smiles. This pretty much ends the video content from Kyle's channel. But there was a comment thread on this video that has since been deleted. So I don't have the evidence. I should have taken screenshots. I shouldn't have let my window reload. So you're going to have to take my word that the following exchange really took place. A commenter on this video brought up a completely unrelated topic, lunar eclipses. And Kyle replied by posting a link to an article from ScienceDaily.com about university researchers making a new discovery related to Earthshine. Kyle's poor reading comprehension or blatant dishonesty was on full display. He asked the commenter if he really thinks that the light and dark parts of the moon look like Earth's continents or reflections of Earth's continents. Why would he ask such a ridiculous question? He asked if the commenter thought Earthshine had only recently been discovered. He repeated those questions to the commenter with various different wordings, giving the impression that Kyle thinks that these researchers believe that Earthshine, which was recently discovered by them, causes reflections of the Earth's continents to appear on the face of the moon. This is, of course, complete and utter tosh. Let's look at what the researchers actually said. Researchers from the University of Melbourne and Princeton have shown for the first time that the difference in reflection of light from the Earth's land masses and oceans can be seen on the dark side of the moon, a phenomenon known as Earthshine. Now, there's nothing earth-shattering about Earthshine. Earthshine has been known for quite some time. You can see it, especially when the moon is in its crescent phases. You can see that the part of the moon's surface that is not directly illuminated by the sun is nonetheless faintly illuminated. And the explanation for that is that light from the sun that hits the Earth reflects off of the Earth. Some of it reflects off the non-illuminated portions of the moon, and some of that light is reflected back to Earth so that we can see it. The paper is published in this week's edition of the international journal Astrobiology. This is from April of 2009, so this is more than 10 years old. Sally Langford from the University of Melbourne School of Physics, who conducted the study as part of her PhD, says that the brightness of the reflected Earthshine varied as the Earth rotated, revealing the difference between the intense mirror-like reflections of the ocean compared to the dimmer land. Okay, so what these researchers are saying is that the amount of light that the Earth reflects onto the moon depends on the face of the Earth that is positioned to reflect that light to the moon. The ocean has a higher albedo. It is more reflective of light than the land masses, specifically the darker land masses. I would assume that cloud cover would be more reflective than non-cloud covered land. So this is the first study in the world to use the reflection of the Earth to measure the effect of continents and oceans on the apparent brightness of a planet. They are not saying that they can see reflections of the ocean and continents on the surface of the moon. What they're saying is that they can tell what part of the Earth is reflecting light to the moon based on how bright the Earthshine is. The 3-year study involved taking images of the moon to measure the Earth's brightness as it rotated, allowing Ms. Langford to detect the difference in signal from land and water. Observations of the moon were made from Mount Macedon and Victoria for around 3 days each month when the moon was rising or setting. The study was conducted so that in the evening, when the moon was a waxing crescent, the reflected Earthshine originated from Indian Ocean and Africa's east coast. In the morning, when the moon was a waning crescent, it originated only from the Pacific Ocean. When we observe Earthshine from the moon in the early evening, we see the bright reflection of the Indian Ocean. Then as the Earth rotates, The continent of Africa blocks this reflection and the moon becomes darker. That is what the researchers discovered. And this is apparently beyond the comprehension of Kyle Adams. Or maybe he just didn't bother to read it. So there you have it. Is Kyle Adams fit to be a professor of earth science? Well, perhaps he is fit to be a professor at the Flat Earth Institute of Science, which is a fictional organization he devised for his videos. Now, you could argue that Night Sky Jeff, or realistically speaking, as I had previously been known on YouTube, is a fictional persona. My name is not Night Sky Jeff. My name is Jeff, but my name is not Night Sky Jeff. Night Sky Jeff is more of a nickname that I chose for myself in the world of amateur astronomy. Kyle's approach is completely different, calling himself a professor, because he does, after all, profess beliefs, and dreaming up some institute from which to profess his beliefs, to teach with apparent authority. I don't plan on doing a second video about his content. His channel represents some of the worst pseudo-scientific thinking in the flat Earth community today. Many flat earthers claim to understand the globe model, which is why they claim to be able to debunk it. But as Kyle has shown us, he either doesn't understand it, or he has to present a false version of it in order to debunk it. So next time, flat earthers, if you're going to try to debunk the globe model, argue against the real globe model. Don't set up a straw man, because I'll knock it down faster than you can. I'm Night Sky Jeff. Keep looking up.